Alright, now after that first video, I'm sure you are thoroughly confused in many ways, shapes, and forms. How is this useful? Why the heck did we do that? Why am I doing an integral with another integral inside of it? Okay, so I admit, a little bit weird, but I've just recopied it right here. This is what we use for integration of parts. So here's an example. I got the integral of x e to the negative x dx. Okay, so how do I deal with this? How do I do this integral? And, you know, you could try to deal with this in many different ways. You could try to use substitution, but go ahead, try it. It's not going to work. No matter how you do it, it's not going to work. Okay? Like I say, don't believe me? Go ahead, try it out. If you make xu up here, then d would be 1. It wouldn't be x. You got an extra x there. If you make this xu, then the same thing. If you make e to the xu, then the derivative is e to the x. And so you got too much stuff there. It's not going to work out. There's no product rule for integrals, right? There's no way easily to simplify this. So we're kind of stuck right now, okay? So what we're going to do is we're going to do integration by parts. So how we're going to do this is we're going to make the x our u. Now the reason for that is because in the second part you'll notice that the u will be u prime. And if u prime, the derivative of x is now 1, which means I'm going to have less variables on the right hand side than on the left hand side. The v prime is going to be the e to the negative x. So I'm going to write these over off on the side. I'm going to need to know u and u prime. I'm going to need to know v and v prime. Okay, so these should be easily integratable functions. So u is x, which means that du is 1 or 1 dx, right? Either way is fine. I think 1 is fine. That's just the derivative. And then v prime is e to the negative x. So I need v, so I need to take the integral of e to the negative x, and the integral of e to the negative x is negative e to the negative x. If you need help with that, go watch a different video, remind yourself how to do integrals. Okay, but that should be a fairly straightforward integral. And so now I can rewrite it using this formula. So I rewrite x times v, which is negative e to the negative x, so negative x e to the negative x, minus the integral of u prime, which is 1, times v, which was negative e to the negative x, dx. And yes, there is still an integral, but now this is an integral that is actually integratable. Now I'm actually going to go ahead and change these to pluses. I don't like negatives. They mess with my brain. So we'll just kind of do this, and now we've got e to the negative x. So now I can actually take the integral of e to the negative x. The negative x e to the negative x still just kind of hangs out there. The integral of e to the negative x is, of course, e to the negative x, and then you put the minus in front. And then because this is a indefinite integral, you do need a plus c on there. You can put it now, you can put it later. Okay, there is a common factor here, so you could take out the e to the negative x if you wanted, and then you have negative x. Maybe even take out a negative e to the negative x, which would leave you with x plus 1. And then, of course, you just got your c that's hanging out there at the end. All right. So that's the gist of it. We just used integration by parts to help us solve this equation, this integral that we wouldn't have been able to do otherwise. All right, let's go ahead and let's do another one. Why not? So this time we love our trig function. So let's do trig x cosine of x dx. Okay. Again, we need one of these to be u and one to be v prime. U needs to be the one that when I take a derivative of it, it's simplified. It becomes smaller. It breaks it down. And so again, x is going to be u. So u is x. U prime is 1. V I don't know yet, but v prime is cosine of x. So if v prime is cosine of x, then we take the integral and we get sine of x. Remember that going this way is just going to be the integral, the antiderivative, sorry. Okay, so now I rewrite the problem, and so I say, okay, I've got u times v, so x sine of x minus the integral of u prime, which is 1, times v, which is sine of x dx, and then I can actually take the integral of sine of x, so I end up with x sine of x And the integral of sine of x is, of course, plus cosine of x, because the integral of sine of x is negative cosine, so I got a negative negative. And then you, of course, have your plus c at the end. And there you go. Not so bad, huh? Okay, so yeah, integration by parts is a little bit weird, especially at the beginning, but it actually kind of works out kind of nice. Okay, let's do one more just because we can. Because I'm in charge and you have no say in the matter. Okay, let's just go over here and we'll do the integral of 4x plus 5 times the natural log of x. Okay, so again, here we go. This is another weird one. You've got something that's being multiplied by something else. So again, we want to do u and v. All right, now if we think of this, if we make this u, because I'm looking for a u and a v prime. So if I make this u, I'm going to have u equals 4x plus 5. And then, yeah, that'll make the u prime nice. So that'll be u prime equals 4. And then v and v prime. But if I make v prime natural log of x, I got a problem. Because I don't know how to take the integral of the natural log of x. So that didn't simplify the problem. And so you can't just get used to always choosing the simple x, the linear term. Okay, you have to pay attention to what the other pieces are and what might actually be the easiest way to do it. All right, so we say, all right, well, that didn't work as well as we had planned, so we get rid of it. And this time, let's try making the natural log of xu, which means the 4x plus 5 will be our v prime. So u equals natural log of x. And in this case, the simplification was the fact that u prime is now 1 over x, so we're getting rid of the natural log. We got v prime being 4x plus 5, which means that the integral, or the antiderivative, notice that here we're not worrying about the c. You don't have to worry about the c as you're going back and doing the antiderivative there. Okay, because whatever the c is, it's going to disappear when you move over to this other piece. So we're not worrying about the plus c until we get to the very end. The plus c at the end will take care of all of that. Okay, so we go v, and v equals, well, we need it to be x squared, and then it'll be a 1/2 in the front, so 2x squared plus 5x. All right, and so now we can just put that in. And so you'll remember, here's our formula right up here. So I've got the u, which is natural log of x, times v, which is 2x squared plus 5x. And then we go minus the integral of u prime, which is 1 over x, times v, which is 2x squared plus 5x dx. And you'll notice that from this point we can actually distribute the 1 over x, and this will actually be doable now. Now, as I'm finishing this problem, please note that this is not a magical formula that will always solve our problems, right? There are many problems in this world that cannot be solved through use of integration by parts, world hunger being one of them. But with what we have, it will work in many situations when we're trying to deal with integrals. All right, so at this point we can take the integral. We'll have 2x squared plus 5x times the natural log of x, and then we'll do the integral, which will be x squared, and we'll put the 1/2 in front, plus 5x, and you'll have your plus c down at the end. And that's pretty much it. I mean, I guess you could distribute the minus. There's some simplifications you can do, but we've accomplished the integral. We took the integral of this Mr. Ugly up here, and there you go. Yeah, it's another Mr. Ugly, but, you know, that's what we got. All right, so if you, I encourage you to watch the next video, because it shows an example of a time when we have to do more than one, all right, more than one integration by part, but you'll see. All right, good luck.